Good evening, everyone, and welcome to episode 3 of the Explorer series, Microservices War Stories. Thank you to everyone for joining us this evening, and we hope that you guys are going to have a really great session with us. So, to introduce our panel of experts this evening, first up is Gihan De Silva. So Gihan is a senior tech lead who right here at Capstars, who has experience in coding and mentoring teams in collaboration with some awesome individuals around the globe. He is also an AI enthusiast and loves to build new things that do fantastic stuff. His technical areas of expertise include solution architecture in several different business domains, along with enterprise systems and web and mobile apps. In terms of tech, Gihan is a wizard at PHP, JavaScript, and microservices, just to name a few. So next up is our other speaker, who is Mr. Tushara Jayasinghe, who is the co-founder and CTO of Future Labs. So Tushara has over 15 years of experience in software engineering, specializing in GUI technologies, cloud-native applications, serverless architecture, and machine learning. He was the GUI architect at LSEG Technology and also held the chief engineer position in LSEG's Technology's advanced platform team. He's also a passionate trainer and loves to share his knowledge and experience with peers and budding professionals in the software industry. So, with two amazing tech experts on board, I'm sure we're going to have an incredible session today. First up is Gihan with an introduction to microservices architecture. So, Gihan, the floor is yours.
Yeah, thanks, Sarah. Thanks for that wonderful introduction. And hi, all, and welcome to the Explorer Series 3 webinar. Today, we are going to talk about microservice architecture. And during the webinar, I'm planning to talk about main design patterns used in microservice architecture with a practical example. And due to the time I have, I may skip through some boring theoretical parts and try to explain things by building an application. So that way you can absorb the most of this webinar. So let's get to it. I hope you can see my screen. So first, let me give you a brief introduction about myself. My name is Gihan De Silva. So you can follow me on Twitter and our blog, and this is my LinkedIn handle. And I've been working as a software developer for about 10 years now, wearing many hats. So I hold a BSc in Computer Science and Technology from UNS University. So, and during my free time, I used to play my bass and work on some interesting Raspberry Pi projects. And yeah, so what are microservices? So microservices, if I try to tell it by the definition by the book, microservices are small, loosely coupled application or services that can fail independently from each other. When a microservice fails, only a single process in the system should become unavailable, while the rest of the system remain unaffected. And when we talk about a monolith application, we have a solid principle. So for microservices, we have something called ideals: interface segregation, deployability, event-driven, loosely coupling, single responsibility. So these are the main design principle for a microservice. In a nutshell, traditionally, so this is monolithic versus microservices. Traditionally, software developers created a large monolithic application with a giant single database. A single monolith would contain all the code or all the business activities in an application performed. As the application requirement grew, of course, the monolith also had to be grown. But when it's come to microservice, applications are simple to build and maintain when broken down into smaller services that work seamlessly together. And these services communicate with each other through a message passing module, like an event bus. So these are the pros that we can think of having a microservice. So, um, so there is no single point of failure in microservices. So you may be wondering why this is. You may have seen this cutscene from cutscene if you are an Avengers fan. Here, Nick Fury was getting hammered and he's trying to escape from bad boys. And while he's at it, he talks to his smart car and asks about the status of different parts of the system. And car always replies with that the feature is damaged. So out of the frustration, Nick asks, then what is not damaged? Then car replied, air conditioning is fully operational. So at the time it was really funny. So it looks his smart car also has some microservices characteristics, even though some part of the system are not working, some works since they work as independent unit. So with that thought, let's move into cons. So these are the drawbacks of microservices. There are a couple, and most importantly, it's too complicated for small companies. So um, yeah, so this is a typical architecture diagram for a microservice application. So here you can see we have a web client and several API services, and each microservice does have its own database. That way, they can actually one team can take over service one, whilst another team can take over service two, another team can take over service three, and that way these teams can work independently without needing to support from the other team. So all these API services actually connected to through API gateway, and so that's the other pattern. So okay, sorry about that. And so each service, as you can see, actually never communicate directly connect to each other's database to get data. But how they communicate to each other is by using an event bus. So if service one need to publish some data, so it will publish it to event bus, and service two might catch it from here by consuming the event service. And authentication and authorization is also a very big part in microservice architecture. So there are a few ways to implement this. So first one is to create your own authentication and authorization platform as another microservice. Or the second option is have piggyback on an external authentication or authorization platform. For example, Auth0 or AWS Cognito would be great examples for that. And data management or communication between services is the most difficult part of microservices. To help with it, we usually use a few design patterns: CQRS, event sourcing, and Saga. So I'm not going to explain these terms right now due to the time I have, but I will explain these things with my example. So without taking much more time, let's try to build something. So I'm going to build a blog. I hope everyone is familiar with the concept of a blog. At some point, some of you may have built a blog by yourself, and I know some of you are bloggers, and at least you have read a blog. So I think you know the basic concepts of blog. So to build this microservice-based blog, I'm going to use these technologies as the event bus. I'm going to use AWS Kinesis, and as the infrastructure, of course, it's going to be AWS. And for the programming language, I will be using Node.js, and for the framework, I'm going to use serverless. And as for the database provider, it's going to be MongoDB Atlas. And for the database, I will be creating MongoDB databases. So I will share the code with you at the end of the session. And to run this demo, you will need a AWS account and a MongoDB Atlas account and a Postman tool. So here's the problem in brief. So if we look into this, sorry, okay. If we look into this picture, so here's a blog. Um, to get to populate data into this screen, we would need all the post and all the comment, preferably within by calling a one API call. And if we navigate into a single post, we would need the post data and as well as the comments associated with it. And there are two operations associated with it to make it to run the blog. We need to be able to create posts and we need to be able to create comments for a given post. So this is the architecture of this blog microservice. So here you can see we have a post service, comment service, and a query service. And all these services are connected through AWS API gateway. And for the event store, I'm going to use AWS data stream, Kinesis data stream. So these two parts I haven't actually implemented in the demo, but it's pretty much easy. So I will briefly explain about the event sourcing pattern here. So basically you can log all the events into the event store by using AWS Kinesis Firehose and dump it into the AWS S3 bucket. And if you ever needed to actually replay all the events for some reason, you can actually use Redshift and get the data back to that particular service that you are referring to. And to make this picture a little bit clear, I have another image. So here, this is more detailed view. So we have a post service and it create post. Once we successfully save the data in our post service, what we are going to do is we push or publish an event to the event bus with this data. So we have an event name like post create, and there's a data object, obviously the post data object. And we have event consumer to consume any incoming events that is coming from the event bus. And we have a comment service. When we create a comment, we will push an event to the event bus like this, and we will get the data back into the event consumer. And every time we create the push an event, the query service also getting event into its event consumer. At that time, so remember that query service also does have a database. So what we are going to do is we write to our query services database with this data. We catch these two events and process it. Okay, now let's go into the fun part. So here's the code for it. So this I do have 3 projects here. So if as I mentioned earlier, so each project actually handled by a separate team. Imagine it like that. So it will be much easier for you to understand the concept. So for the example, actually I have used serverless framework to build the service, and for all the services, post service and the query service as well. But there is no restriction here. You can build the comment service with the serverless framework and with the MySQL database, and you can build the post service with MongoDB database and with maybe serverless Python framework. And for the And query service, you can actually build it with Java or maybe with Redis database. So there's no restriction in the technologies that you are being used. Only the concept is the important part. So since all three projects are pretty much similar, I'm just going to explain one project. So here we have the comment service, and I'm using AWS parameter store to store any application secrets. So let me just quickly go back here. And so these are the parameters that you need. First, you need to create three databases in MongoDB Atlas. So those are one for comments, one for posts, one for query. And you need to store those database URLs in here. And also you will need to create a Kubernetes stream like this. It's pretty much straightforward. Keep the default value and just add the ARN value here and the stream name here. And once you do that, you are ready to go and try to deploy it. First, these are pretty much standard things for a serverless framework. We are using Node.js 14x, and I'm just using 256 MBs as the memory size. And I have taken these variables as the environment variables. And we have, most importantly, two functions here. This part is the most important part, and that I'm going to describe. Here we are going to create a comment, and here also we have a event consumer. So here we have a handler called create comment in the comment service. Let's look into that. So what it does is, so when we make a request, it will just come through here and create a comment. And once we successfully save it to our comment database, and we are going to push an event called comment create with the comment object. So that way, our event bus can catch it, and when it reach to the query service. So let me just quickly explain here as well. So here we have another event consumer for the query service as well. So in that project, we have another event consumer. So here is what it looks like. So this is the processing part. We have post create. So here we are going to create post, and when we catch this event, we are going to create a comment. So likewise, we can do this. So for the example being, I'm just going to show you how to deploy it. So let's before deploying it, actually I have deployed all the services. Let's just quickly show you. Let's deploy our comment service. All right. So all we have to do is SLS deploy propose. This command actually will deploy the whole stack into AWS, but you only have to do is once. Unless there is a change in your serverless YAML file, you can just run this command. And after that, what you can do is you can independently just can update each of the functions and deploy. So it's less time consuming than this. So let me give you a quick example of how it's done. So we have a Postman. So let's create post first. So this data actually come from another example I tried previously. So if we actually go back to our project, post service and the post model, post schema. So we have a title, description, and created that. Created that value is being injected during that model is created. Sorry, data is being created. And
Gihan, just to jump in real quick, there are a couple of requests asking if you can increase the font size, or maybe if you could zoom into the screen for it to be a little bit clearer. Yeah?
oh, all right, all right. Okay, how can I increase the font size? Actually, I never had this problem, so let's please give me more time to figure this out.
Yep, no worries. In the
All
meantime,
right.
guys,
Um,
while Gihan sorts out the font size and makes everything a little bit clearer for everyone, we will be launching a live poll for the moment, just to understand if you guys have experience in microservices or if this is something brand new to you. So we'll be launching that poll to go right now. And here we go. It'll be going live.
all right, all set. Can you guys see my screen? Sarah, how is it now?
I do
That's
think it's
that's
a little
better.
clearer.
Readable?
Yeah, yeah, that's
Okay.
better. Yeah.
All
Right.
right, all right. Sorry about that. So actually, I didn't read the questions or comments that you are putting in.
Yep, we do have quite a number of questions also coming in. So thank
Yes,
you guys for all the questions. Um,
I will take all those things at the end of the
I
session.
think that
So,
would be best. So keep the questions coming in, and Gihan will take them shortly. Gihan, back to you.
okay, thanks, Sarah. So here we have the in post schema. We have title and a description, and I created that value. So let's try to create a post then. So let me increase the size here as well. I'm not sure. Yeah, here we have. Okay, now it's much better, isn't it? Okay. Mm, I'm just going to create a new post, and if you actually see, so okay. Now our current service has been deployed. For the record, I actually deployed all three services before. I'm just redeploying it. So these are the endpoints for the comments. So you can get it here. And so let's create post. So these are the data I have put into the request body. We have to set it as raw and here type as the JSON. So we get a response like this, an ID. And yeah, let's just for now just copy this post ID and try to create a comment as well. Okay, comment for let's say comment for my second post. And before that, let's go here and check this API from our query service. Okay, we have data. Okay, let's add the comment as well. Okay, cool. So if you look into here, and let me just try to run this. Okay, right. This is the post, and this is from actually the query. So just to explain what happened here, I'm not actually directly fetching data from so this is the query service. We have two separate services to get API calls. I'm not fetching the data directly from our post database or the comment database. Instead, we have a separate database for our query, and the structure is like this. We have the auto-generated ID and post ID and post object and comments. And comments are stored as an array like this. So yeah. and we get the result like this. Just for another example, let's try to fetch this post data by here. So here we get a single record for a particular post, and comments are added one by one into array. So that pretty much it. I hope you understood something, and so I hope actually you got the basic knowledge and how microservices actually work. But before I end the session, so we promised this Explorer series name is War Story. So let me tell you one war story. Um, yeah, let me just quickly. Okay, so war story means. Let me just quickly explain what's a war story. It's not a fighting story. So it's actually things when we try to build, try to develop the mistakes we actually had, we done. So one of the mistake, one of the when if I this actually happened at the beginning of my career. I tried to work as a freelancer for another company in Australia. So the, there was a little bit of communication gap, and the documentation was not really well. So if you actually look into this structure here, so all the communication between services are happening with the event. So the event structure, event names should be standardized. So it should be documented, because if I correctly mentioned, post service is in this example actually done by a separate team. Comment service is done by a separate team. So if the and also the query service is done by a separate team, just assume. So if this post service developers actually didn't publish what are the event names and the data structure for their data object, these guys actually don't know what to expect. So there's a documentation issue back then. So we try to we actually overcome it by using actually API documentation tool Swagger, and also it was a very good experience for us as well. And with that thought, actually I'm going to end the session, and thank you for joining the session today. And over to you, Sarah.
Cool. Thanks, Gihan. So I think during your demo, there's actually quite a number of questions that have come in. So let's just run through a couple of them. So one of the questions actually is from Shanga, and that is, why would we choose AWS Parameter Store over AWS Secrets Manager?
Yeah. Which one is it?
It's
Yeah.
yeah, it's in the chat box.
Actually, you can use both. Actually, for it's like a very much personal preference, because I have used parameter store for a long time for a lot of projects. So I started using it. That is something I think I also need to look into, the AWS Secrets Manager.
Cool. So the second question is from Lakmal, and it's, do we need an event bus? Can't we use the same API gateway to communicate among the microservice?
Do Lakmal Vimaladasa
Yeah.
is that one?
Yeah.
How we can divide existing monolith application into that?
No, Gihan. The previous question is on do we actually need the API gateways to communicate within microservices, I guess.
To communicate within microservice, you don't need the API gateway,
Yeah.
but the overall idea is to facilitate the client to access all the services. So for a particular client, for example, in this example, let's say our blog, we have a React.js based client application. So that client does not need to know what are all the implemented services. So it for the client, it's just one single endpoint or
Interface.
a
Yes.
domain. So that's the reason we are actually using API gateway to integrate all the services and get the access to our client.
Yeah. So the API gateway is only for the outside world.
Yeah.
Yeah.
We have another question from Lakma, which was how can we divide existing monolith applications into microservices? Are there any rules? For example, the existing Laravel application has customer, inventory, users, subscription modules. All modules defend each other, so how can we break them into a microservice?
First, I would advise to find the least interesting module. That means a module that doesn't do a lot of impact to the existing monolith application. From that point, you can start implementing event bus and try to convert that module into a service. That way, you can actually build up the confidence about the technologies you are using. So afterward, you have to pick another service and try to migrate into microservice. I think that's the best way to do it.
One more question from Nipuna, and that is what will happen if one microservice is down? How could we minimize the effect on other services?
Actually, this is where the event sourcing pattern comes in. So, event sourcing pattern means so it actually logs each and every request to an event store. In our example, it's the S3 bucket, but I would advise to have another store as well, like DynamoDB, to store all the event data. So, for example, one service goes offline, but the event bus is still live, and there is a data retention period in the event bus, and also you have already saved those event data into your another database. So if actually you lost some data, if service went offline, you can actually get those data from that event store database and do a replay of all the events that happened during that downtime. And that way you can actually get the backup and up and running back to its normal.
So looks like we've got a lot of questions
Yes.
coming in.
Questions. Yeah.
So we'll take one more, and then we're going to dive into Tushara's session. So just one more question that we're going to get here is from Nuan, and that is how big or complicated should a project be in order for you to consider developing in microservices as opposed to monolith in nature?
Sorry, actually, I was. Can you repeat it,
Yeah,
please?
it's from Nuan, and it's how big or complicated should a project be to consider developing in microservices as opposed to monolith nature?
Mm, okay. So let's assume it's actually you have to decide it. So, for example, if you think you can't actually move forward with your current application, the problem with monolith is if you have to do a deployment, the application is too large. You have to tag another version and upgrade the whole application, even though if it is just a small change. But if it is a microservice, what you can do is you can actually, you know where to put the update. You can update only that part. So to answer your question, um, there is no really benchmark. But if you consider like this, if you feel it is better off separating this part because, for example, let's say we have let's take this example as we have a blog, and down on the road, a project manager asks to develop a dashboard to log all the events or the analytics analytics dashboard. And analytics dashboard is very much rely on read data on the existing data. What you can do here is you can separate that only analytic dashboard part as the first step as a microservice and have a separate database to it. So that way, even your application goes down for some reason, your dashboard will survive. And same goes, I can actually think of another example. Um, this is actually the best one, should be for a shopping cart application. There's a payment gateway integration. So that's a very good point to you where we can apply microservice. So the payment processing part can be actually divided into separate service, or separate microservice, even though your application is a monolith.
Great. Thanks, Kihan. And thanks for all the questions coming in as well. So just check the poll results as well. And it looks like more than half of you actually either have not had any microservices projects in production or have learned about it but never really put it into application. So I think that the introduction has definitely been of value to you guys. And now, which is going to be of more value as well, is going to be Tushara's session, which is going to be a deep dive into microservices architecture. So hope you guys enjoy the second session, which is Tushara's. Tushara, floor is yours.
Yeah, thanks, Sarah, and thanks, Kihan. Hope you can hear me. Let me share my screen. Can you see the screen? Sarah, can you see the screen?
Yep, can see.
Right, okay. So I think Kihan discussed about the theoretical aspects and bootstrapping a microservices application. I'll touch upon my experience working with mission critical microservices apps and machine learning related microservices apps in next 15 to 20 minutes. So let's talk about real world battles in microservices. So these are the main things that we are going to discuss. So we'll discuss architecture which can support machine learning applications as microservices for prediction purposes, which has functional requirements as more non-functional requirements as well, like performance and security. And we'll talk about how we're going to manage your microservice applications. Like if you have 20, 30 microservices are running in your application, how are you going to manage those? So that's where we use deployment orchestration application like Kubernetes, which again from Google, they are using Kubernetes for their deployments as well. So we'll have a brief understanding on what Kubernetes is and the role of Kubernetes in microservice application. And finally, I think most of the questions are related to this as well. We'll discuss, so I'll share my experience on the things that you should consider on either, like if you are planning to migrate a monolithic application into a microservice architecture, or you are designing a fresh microservice architecture for a potential product. So this is the agenda, or these are the contents that I'm planning to cover during the session. So let's look at our journey in this industry, in the software industry. So I am Tushara. I started my career in year 2005, passed out from University of Moratuwa. I first joined an organization called Mubasha. Now it's Direct FN. That's my first engagement in the industry. I was more into Java, and at that time, I can remember we developed applications using serverless and JSPs, and most of the time they were monolithic applications deployed on Tomcat. But then I joined LSEC Technology, if I can remember, way back in year 2012. Even though at that time also the world was more on monolithic applications. So we developed a JSP and servlet application for a clearing solution for Austrian Stock Exchange. And then gradually the concept of microservices was coming into the picture. So I was fortunate enough to design and involve in two microservices project, large-scale systems. One is a market real-pay system. We use Java, Vertex as the microservice provider, and eventbus as the Hazel cast, and the front end was Polymer. And I think it's in live now. So that's my experience with live production grade microservice application. And we did a target architecture to move exchange or a trading system into a cloud native architecture using microservices. There we use Kubernetes, Redis, and Kafka for message communication, and even so in that system there's a specialty where the states of the microservices should be kept in a separate memory so that if there's a failover, the next microservice can fetch the state from the external memory and continue from that point onward. So that we use Redis as the caching provider. So I would say it was a great experience to work with LSEC technology, and with the current the experience with Future Labs, we are more into microservices, especially in the machine learning aspects, into education technology. So we have our own products for supporting education, like exams, simulation platform, especially for Pearson exams. And also we do projects on machine learning. One project is which it's called Fairly Tax. It's a US based project where you can, for example, you can type your address in web browser, and you get evaluation of your house using machine learning prediction based on the surrounding homes and based on the historical data. So we use like supervised learning techniques, the gradient boosting mechanisms to have that real-time prediction in background using AWS SageMaker as the deployment architecture. From those two projects, I am especially taking our education tech platform, that is the Pearson exam simulation platform, to discuss in more details the target architecture and design and things, how we achieve the non-functional requirements in the system. So a bit of analogy. This is how I understood the microservices architecture. So these pictures are from Ford Model T factory. So way back in 1900, Ford car was a luxury, like the only people who are having money can buy a Ford car. But then when it started, when people started buying the car as a public user car, then Ford realized that the current way of producing cars is not going to work. So he introduces the conveyor belt, and he introduced concepts like dividend of work, where a single person will do only a small task, and by doing that, that person will enhance his or her skills through specialization. So it's about dividend of work and specialization. I personally think that's the same principle that we are applying for software industry as microservices now. So we have small microservices doing a small task, and those services are specialized for that task over the period of time. So this kind of example analogy that I want to demonstrate. So back to our main topic. So I already mentioned that we have two ML-driven microservices application. One is for the Pearson test for English. So it has mobile app, iPad application, and a web application. This exam is if you are planning for migration or planning for higher study, we know that we have to take two exams, either IELTS or PT. PT is different from IELTS where you do the exam in online. The main difference is the marking algorithm. There's no any human intervention to do the marking, even for the essay, even for the speaking that you do into your mic. The everything calculates. The marking is done through machine learning algorithms. So we have a product developed to simulate or they replicate the same functionality where students can come and practice their exams using mobile app or a web application. So I'm trying to demonstrate the architecture behind and how we handle the load in our architecture. And this is the Fairly project that I mentioned. It's a US based project. Again, it uses the machine learning driven microservices, but the deployment architecture is bit different. It's running on AWS and SageMaker, and as Gihan mentioned, the architecture is serverless. We use Lambda and Aurora as the database. But for the PT exam simulation platform, we are running on Google GCP Cloud with vanilla Kubernetes running in the background. So those are kind of functional requirements, but when it comes to non-functional requirements, this is where most of the time we fail. We can deliver functional requirements, but when it comes to non-functional requirements, we sometimes we feel we forget about non-functional requirements. And in our system, the benchmark is to have at this phase one stage 5,000 requests per second. For example, students can practice their questions through their apps, and they will submit their practice questions to the system to get their answers driven through machine learning algorithms. And the overall architecture should be cost effective because most of the services are provided free for the students. So those are the constraints and requirements that we are working with. And these are some of the screenshots from the application. So it has different aspects like speaking, writing, and listening. This is the mobile app. And the right-hand side, it's a screenshot of the iPad application. For example, in here, a student can speak into the mic, and there will be a recording, and this recording is evaluated against machine learning for oral fluency and for pronunciation and for other marking criteria. So let's understand the requirements. So as I mentioned, we are getting a set of requests into the system, and we capture those requests, and we should run machine learning algorithms in background for those requests, and finally create a score report and send it back to the user. So just to refresh our understanding on different words that I'm using, Kubernetes, we typically call it as K8s, is a container orchestration platform by Google. Kubernetes, there's a separate slide to discuss the internals behind Kubernetes as well. And also, there are some augmented Kubernetes offerings like Google Cloud Run and Fargate. Fargate is from AWS. So underlying technology is the Kubernetes, but there's a wrapper layer on top of that to augment some of the services. But I would say there are limitations as well in terms of flexibility when you are working with such services. And for inter-microservice communication, we use Google Protobuf. It's a language neutral protocol for serializing messages and deserializing messages. For example, if one microservice want to send a message to another microservice, we pack it as a protobuf message. And message bus, I think you already aware of message bus. The simple example to demonstrate a message bus is Kafka. So most of the services are running on top of Kafka to provide the message bus service. We use Google driven message bus called pub and sub for communicate in between microservices. How does the ML prediction works? It's interesting. So we train the models like using supervised learning technologies. We have the data, and we train the model with the data, and we have the compiled version of the model. I would say the model artifacts is saved. so that we can do further prediction using the model without training the model again. So that's how we do. We train the model, we create an artifact of the model, and we containerize that model and store in a container registry, and Kubernetes will fetch those containers from the registry, and we'll do the load balancing for the machine learning evaluation. There are different types of microservices, so different type of questions based on the trainings. And just to mention the AWS SageMaker. So SageMaker is offering, fully managed offering by AWS to train your data, to deploy your machine learning models on top of high performance machines, and to run your ecosystem by connecting it to a serverless architecture. So for example, the Fairly Tax project is running on AWS SageMaker. And so the architecture of a Kubernetes, just to go through the brief architecture, Kubernetes can orchestrate containers. That means we can allocate some, let's say we buy 2 machines, let's say 2 EC2 instances, and we create a cluster using those 2 instances. So the worker node 1 is one instance and worker node 2 is another instance. So we create a cluster using Kubernetes and give the controlling power for the Kubernetes, saying, Kubernetes, I want 3 machine learning service instances at any given time. So I am the person who is giving instruction using, let's say, the Kubernetes CLI. So it's the responsibility of the Kubernetes to maintain that desired state based on the current state. Let's say one service down, but my instruction is to have 3 services, then Kubernetes will create another service automatically and always try to maintain the desired state in the overall system. So that's how Kubernetes works. Even Kubernetes can provision new machines into the cluster based on the instructions and create a larger cluster, and also scale down the cluster when there's less load into the system. So it's amazing how Kubernetes is taking over the container orchestration platform. So by experience, we know to cater the requirement of handling 5,000 requests per second, synchronous API-driven or REST API-driven microservice architecture would more resources. And also, we know that by experience, the Kubernetes offerings like Google Cloud Run and AWS Fargate have their own limitations, like when it comes to timeouts and when it comes to do flexible deployments, they have their own limitations. Even we tried with Google Cloud Run to run our architecture, but we couldn't achieve the desired outcome with those limitations. And when it comes to SageMaker, I would say it's a well-defined or a well-designed architecture to run machine learning microservices, but it's fully managed. Again, there are some limitations in SageMaker as well. And the experience that we have with serverless architecture, it's good, it's promising, but I would say the tooling system behind serverless architecture, like the serverless framework, the deployment, has limitations. Again, if you are developing a large scale system, I think Gyan is having the same experience when working with serverless architecture. So based on those experiences, we designed the architecture as per the picture. So these are the students or the users who are using the application. We have mobile app and web application. So they will send their score report request into the system. There's a REST interface to capture all those into the system. And then those messages are converted into protobuf. As I mentioned earlier, it's a binary language to communicate in between microservices. And those messages will be kept in input topic in Google PubSub. We can have multiple topics based on the question type for load balancing as well. So there are a set of microservices running in background. So entire architecture, entire deployment is running on top of Kubernetes, and we can create multiple machine learning evaluator microservices to fetch those input messages, do the evaluation logic, and final answer would be, let's say, your oral fluency mark for this audio file is 70, and your pronunciation mark for this audio file is 65, kind of those messages. And the machine learning evaluators will create output messages, and those messages will be kept in this output topic, so that this score engine, which amalgamates those score reports to create a single score report, can fetch those messages and do the processing logic. So there's a need to keep some part of those calculations in memory for efficiency. For that, we are using Redis as the cache. So the score engine will go and create a picture of the temporary results and amalgamate those results and put it into a database, so that the report reader can send that report to the user asynchronously. So there will be a time delay on to this process, and that is again notified for the user as well. We will be giving you a report, let's say, within the next 5 to 10 minutes. So this is the current architecture that's there in production. So I think I already touched the technology stack. For microservices, we use Node for the REST endpoints and Python for machine learning predictions. For middleware, we use Google PubSub and Protobuf as the inter microservice communication protocol. And for caching, we use Redis, and we use Firebase for real-time communication to maintain the real-time communication with the mobile app from the backend. And yes, we have a front end which again developed using Angular. And for mobile and iPad, it's Flutter. Flutter is capable of having a single code base and have the artifacts of running either in iOS, iPad, or in Angular. So we have a single code base, and you have different artifacts you can derive different artifacts from the single code base. So that's the technology stack. And I'll briefly touch upon how the non-functional requirements are catered in this architecture. So we are using the scaling mechanisms in Kubernetes. So Kubernetes has different levels of scaling. Let's say we have 5 different machines, and Kubernetes is controlling this machine, and Kubernetes will take decisions on where should I deploy this microservice. When it is deployed, the name that we are using is pod. So we have pod for a different service and a set of pods. Let's say 5 pods doing machine learning evaluations, and 3 pods doing request handling. So we have 8 number of pods. And if you think that if you given the right parameters for Kubernetes, saying depending on the memory and depending on the CPU usage, if you want to scale up the resources for a given pod, yes, Kubernetes will do it. That's called vertical scaling. You have a pod and you augment that pod with some resources, memory and CPU. That's one level of scaling. And another level of scaling is the horizontal scaling, where Kubernetes will create new instances of pods from the same microservice up to a maximum parameter. Let's say 3 pods, 4, 5, 6, they can grow. And if there's less load, those pods will be shrink down to a default value. That's called horizontal scaling. And even if that is not enough, vertical scaling, there's limitation, and horizontal scaling, not enough memory and capacity in the cluster, Kubernetes can provision new machines or new EC2 instances, if we talk from AWS terminology, and attach those instances into the cluster and grow the cluster to cater the incoming load. And if there's less load, shrink the cluster. So that's called the cluster scaling. And even it has, apart from those default scaling mechanism, it has a custom metric driven scaling as well. For example, we can write scaling logic to see the incoming number of messages in the queue. And if there's a processing delay, let's say queue is growing continuously, when that threshold is passed, Yes, we can instruct Kubernetes to go and create new pods or new machines by increasing the cluster size. So that's I would say, another different level of scaling mechanism provided in Kubernetes. So that's the like the we are coming back to the end of the presentation. So just to conclude, the conclusion based on our experience, it's always good to do a POC, a small POC with all the wirings in place if you are planning for a microservice architecture, so that you can prove, you can review your architecture and design. Even you can choose the right technology for the right purpose. What's the best cloud service provider? Is it AWS, or is it Google, or can we manage our own cluster with some machines? So happy path testing, a message would come from the API gateway and it will go through the service bus and results is generated. So you can prove your design and the architecture. And always, I think I always I mentioned this as well in my beginning of the session. As developers, we are always good at meeting functional requirements, but when it comes to non-functional requirements, performance, can this system create supports 5,000 requests per second? What happens if the load increases? What happens when these machines are connected through a network? How are you going to ensure the security of the system? And CI/CD, like continuous integration, continuous deployment, is a must when you have multiple microservices in place. If not, it's going to be a mess when it comes to development, deployment, and even testing. And most importantly, what is our test strategy for the entire system? How are we going to test those microservices in isolation? How are we going to test those in a real production environment? What are the bottlenecks when we are connected to a AWS cloud provider? Can we do the testing locally, or do we need to do the testing in a cloud provider? How we provision multiple accounts to do the testing, multiple environments, UAT, QA, and dev. So those are the things that we should consider when developing such systems. Yes, cloud vendors, they have their own limitations. So don't trust too much on them. So sometimes you would think doing it using vanilla way or the old fashioned way would be beneficial. And finally, I'll conclude my presentation with microservice architecture is not a silver bullet. Don't migrate to microservices architecture for the sake of doing it. That's the final advice that I can give you before concluding my presentation. And thank you very much for listening me for that 20 minutes. Thank you.
Thanks so much, Tushara. And I do believe we've got quite a number of questions still unanswered. A couple more actually that have come in while you were speaking. So let's open up the floor now for questions to both Gihan and Tushara. Either one of you can take on the questions as you all see fit. So pulling on from some of the questions that we had from earlier, this one is from Isuru, and he has asked, can't we use the domain-driven design to divide microservices?
Gihan?
Yeah,
Yeah.
I was hoping that you would take it. So, yeah, actually, we can demise something called we group similar microservices together. So, that is also another practice we do. It's
Yeah.
actually possible.
Okay. And the next one is from Manoj. It's, what are the best practices for a beginner to learn about microservices?
That's a good question. Like,
Quite a broad question, I feel.
yeah, so yeah. Uh, so I think best way is it's from Manoj, right? Best way is to get hands-on experience. I don't think there are good recommended courses that you can learn. I haven't used, but best way is to do some hands-on working by creating a sample application. Let's say you choose one technology, let's say Spring Boot, to bootstrap a microservice application. You create a small API gateway and link those services using a service bus. And by that way, you can learn more fast than reading or following a course. That's how I think. It may not be the right answer, but that's how I think.
Yeah.
Yeah.
Right. So
I
this one,
can add a little more to it as well. So if you actually interested learning the theory part of microservices, actually you can check microservices.io,
Mm.
and it's a book author called Chris Richardson, and it does have great information that might interest you as well.
right. So the next question is actually from our backlog of from Gihan's session. So this one is from Amit, and it's how do we version the events? Is it better to create a new event object, or can we update the existing event object? Let's say we have to add new fields to the event object. Oh, I think
I,
Gihan's actually already
I
answered.
actually answered it, but if Tushar has a better answer, I think we got it.
Sorry, I was reading the questions. So is it on version controlling?
The events.
Okay. So if your system is running in production, it's better to have the version controlling for events so that you can do like A/B testing where you can have set of services having new protocol of the events and set of services running the old protocol of the event, and you can even test your new services before moving that into production using orchestration technologies. I think best way is to have the version mechanism embedded within the message itself.
Right. I think the next question is actually connected, it's somewhat connected to that. It's from Amit, and it's when we are developing event driven microservices, it will take some time to consume data, like a query service. How do we overcome those issues, and what would be the best way?
Uh, to answer that, I think it's not binded to microservices. I guess like if you are developing a monolithic application, this type of performance issues can occur anytime. So even it's monolithic or even it's microservice, it's independent of the architecture. I think the question is more towards in microservices architecture, it's comparatively low than monolithic. I would say it's not, because you can design the system such a way to test your performance numbers. The architecture and the designing is the main principle here. It's independent of whether you are monolithic or whether it's microservices.
Right. So the next one is from Lakmal. How can we divide existing monolith applications into microservices? Oh, no,
I
wait.
think I have already answered.
Yeah.
Yeah, sorry about that. Next one is what's the best way to intercommunicate between microservices? gRPC, event-driven REST, etc.
Gihan, would you take it or?
Yeah, I think you can do it.
Okay, so I think again there are many ways of communicating between microservices. Either you can use REST, or either you can use event bus driven communication, or there's a third way of doing that. You can have peer-to-peer communication using clustering mechanism like Hazelcast. So again, it depends on the requirement. So if you can rely on REST, if there's no any performance requirement, you have enough time to reply for the user to do the calculation, then you can go with REST. If you have a real-time streaming application within microservices, then you should go for peer-to-peer TCP communication. And for our use case, we use Kafka kind of a publisher-subscriber mechanism for inter microservice communication. It's again depend on the requirement.
Cool. Thanks, Tushara. So the next one is from Shankar. and it's microservices and cloud goes hand in hand. What is the best cloud vendor to learn in 2021? Would it be AWS, Azure, or GCP?
It's it's debatable.
Yeah, I only have
Yeah.
experience in AWS and GCP.
Yes. I also don't have experience with Azure, but yeah, if it is a Kubernetes vanilla Kubernetes offering, I would suggest to go with GCP. It's more flexible than AWS, but for serverless architectures, AWS is the best in terms of Lambda and serverless databases. GCP is far behind that offerings. Again, for machine learning, those two vendors have their own offerings like Colab and other services, and AWS has SageMaker. It's there's no right answer for that as well.
Right. So then there's another one from Asiri, and that's when will the reinforcement learning be used for predictions as such?
Right. So in our case, we use supervised learning. It's not unsupervised learning. So we have set of historical data, and based on that data, we do the prediction. We use support vector machines and like GBM for both projects. And again, we do benchmarks on these different algorithms to check the prediction rate, and based on the prediction rate, we choose the right machine learning algorithm. So we do same data set, we train using different algorithms. Let's say cat boost, right, GBM and support vector machine. If cat boost is the good predictor in terms of results, then we'll choose that algorithm.
Great. So the next one is from Jayavi, and it is what are the questions that need to be asked when deciding on what flavor of message service to use?
I think it's mainly depend on the experience or choices you have already. Um, if you're actually familiar with Kafka or those technologies, you can go with it. So, and if you're actually more into like AWS, you can go something like with the Kinesis, and you had to actually do a small POC with each of
Yeah.
all the message services, and there are
Yes.
its limitation and advantages of for each of the services. So
Yes.
based
That's
on your
true. Yeah.
requirement, you actually have to find out the what is best for you.
Yes. Sometimes like during the POC time, you will identify those issues. You can't find those issues in the internet. So when you try to implement your requirement, then only you will know these are the limitations in these cloud service providers. If not, the internet would say AWS great, GCP is great, but as soon as you try to do a production grade software, then you will identify those limitations.
Alrighty. Thanks, Tushar. Thanks, Kihan. Couple more questions. So
Yeah.
let's answer a few more, and then maybe we can wrap it up. Because I think if we don't, we'll be here for quite a long time. We've already gone a little bit over. Next question is actually from Chintaka, and that is, how about caching requests within several microservices?
Yeah, I think I already touch upon a
All
part
right.
of that as well. It's like in our architecture, we use Redis for caching requests. So that the web users and the AWS, so the mobile users will be like will be driven through those caches to reduce the load on the database. Redis is a good candidate for that.
Right. So then we have Prima asking, how can we achieve the distribution transactions?
I think Gihan, you had a
Yeah,
slide on Saga. Yeah,
yeah. It's
yeah,
actually related to Saka pattern. So
yeah.
Saka pattern is all about managing the transactions in a distributed system. So we actually have several ways to overcome this. what Saga pattern does is it allows you to orchestrate or have connect with other services and have some kind of series of event. If you are um, familiar with MySQL transactions, it's pretty much the same, but its communication happen in between two or more services. That's a difference.
Right. All right. We have another one from Sanat, and that is, what are the things you need to consider when we convert traditional products to microservices products?
I think it's the same answer. I think from Gihan mentioned, it's not a single theory. There's no single theory behind that. If your monolithic application is working fine, and if generates money, personally, I wouldn't touch it. I will keep it as it is. But they say if there's a drive from the management, if there's a drive from the technology, and everyone is in the same plate, then it's a time to do the migration from monolithic to microservices. But it's not straightforward. I think, as Gihan mentioned, better to start small, try to diverge small services first, try to communicate with those services. Even you can run parallel runs. You have the monolithic version, and part of the monolithic version is a production, and part of it's in microservices version, and then gradually migrate into microservices. And always think about non-functional and security, and are we ready in terms of CI and CD? Do we have a proper test automation to do the testing? And those things should be considered when taking those decisions.
Right. So, taking one more question, and that actually ties into the episode that we had last month, which is, how about GQL, which I'm guessing is GraphQL. Yeah. Right. So that's actually something that we covered last month. But let's push on. What do you guys think? How about GraphQL versus microservices?
Uh, I think conceptually those are two different. GQL is about managing your data, different data sources, in a more organized manner, or in a single defined manner. And microservices is about achieving scalability, upgradability, and I guess even you can use GQL services within microservices as well. So it's not something that we can compare.
Yeah, those technologies actually complement to each other, and
Yeah.
you actually you have to find out what's best for your use case.
Yes.
Right. So, with that question, we are actually going to wrap up today's session. Thank you, Gihan, and thank you, Tushara, for being a part of the third episode of Explorer series and for sharing your expertise and your experience with our viewers. And of course, to our audience, thank you so much for being so engaged. Thank you for the questions that have come in. As always, we are overwhelmed with the questions that you guys have. Thank you so much for being a part of this evening. And to top it off, would just like to also say, if you guys are interested in hearing a little bit about like GraphQL that you guys mentioned, you can always check out the previous episode of Explorer series on YouTube, on the GapStar's YouTube page. And you can check out episode 1 as well, which covered PHP and Laravel fundamentals. So look forward to Explorer Series episode 4, which will be coming soon, hopefully. And thank you so much, guys. Hope everyone has a really good evening.
Thank you, guys.
See
Thank
you.
you.
Bye bye.
Thanks.